we're going to do a quick review of how to use SOHCAHTOA to solve problems involving right angle triangles. So these are the examples that are explained in your notes. I just kind of wanted to give you a chance to kind of listen to them being worked through as well. But nothing's going to be presented here that isn't already in your notes booklet. So you should be kind of following along with that. And then hopefully we can see where all the numbers are coming from, and we'll have a good background on some trig before we move into the new stuff. Okay, so a couple things we want to remember is we can only use SOHCAHTOA when we have a right angle triangle. So we know we have a right angle triangle because we have that little right angle indicator in the corner of this triangle, right? We know that that means 90 degrees. So we know that we can use trig ratios. Okay, so these are our primary, and this is sine, this is cosine, and this is tangent. Okay, and the way it works, if we remember, is sine is the ratio of our opposite over our hypotenuse, cosine is the ratio of our adjacent over our hypotenuse, and tangent, which got blurry all of a sudden, tangent is the ratio of the opposite side length over the adjacent. Okay, so remember that the hypotenuse is always across from the right angle. Try to get that in focus again. So it's always across from the right angle, and then our adjacent and our opposites are relative to the angles that we're considering. Okay, so in this question here we are looking for side length x, and we're given angle 24. Right, we're given the size of this angle is 24 degrees, and we're given this side length is a 6. That's a 6, not a B. Sorry, it looks a little bit like a B, but it's a 6. All right, so because we're given this angle here, and we're looking for this side length is adjacent to the angle that we're given. It's the one that's next to it, right? And 6 is the opposite, right? It's opposite the 24 degrees. So when we think about SOHCAHTOA, when we're dealing with adjacents and opposites, right, oh, look at that, we use tan. Okay, so in grade 10, what I would have had you do is, would have had you set up tan theta equals opposite over adjacent. Okay, and then we substitute what we know. So we know that theta is 24, so we're looking at tan 24 degrees is my opposite, which is 6 in this case, over x. So we have this situation where the value that we're looking for is in the denominator of the fraction. So what we could do is we could multiply both sides of the equation by x, which would move the x up here, and then divide both sides of the equation by tan 24, which would get our x here all by itself. So hopefully you remember that we did that last year, and that really what we can do is we can just swap these guys out. Okay, and honestly, if all the calculations you would have done in scale actually kind of lend themselves to all of our trig calculations. So lots of cross multiplication is going to be happening in this unit. In any case, we get x equals 6 divided by tan 24. And this is where you need your calculator, and you're going to need to check that your calculator is in degree mode. So it might be a little bit hard to see with my calculator here, but I have this little D in the display. If you have a little R or RAD, you gotta get your calculator out of that mode. In applied, we don't have to worry about anything but degrees, which is great. In order for me to do that, I have to go Shift, Mode, and then I press 3, and then that gets me into degree mode. Okay, so some of you might have like a little degree button that you press, and it has a little arrow on it, and it moves you between degrees, radians, and gradians. Don't worry about any of those. Just make sure you get yourself into degree mode. Otherwise, your calculations are going to be completely wrong. Okay, so I'm just going to press 6 divided by tan 24. And I get x equals 13.476. And then this is a length, so it should have some kind of unit. Okay, the question in the example doesn't have a unit, but it should have some unit of length because it's a side length of a triangle. It has a measurement like centimeters or inches or kilometers or something like that. And then what we want to do is we want to think about, is that a reasonable answer? Is 13 a reasonable 13.48? Is that a reasonable number compared to this 6? Well, remember that the smaller the angle, the smaller the side length opposite it is. Okay, so this is 24 degrees. This angle is going to be 90 minus 24, which is 66. This angle here is 66 degrees, which is a much bigger angle than 24. So it makes sense that the side length opposite of 66 degrees is much longer than the side length opposite the 24 degrees. Okay, so it's a really reasonable number. If we would have got something much smaller than 6, let's say we put something in our calculator wrong, lots of people do things like tan 24 divided by 6, and then they would get a number like 0.07. This length being 0.07 doesn't make sense. Okay, so that we always want to do that, especially now that we're in applied and everything is kind of a real world kind of scenario. Okay, so that's how we would use our calculators to solve for a side length of a triangle using a primary trig ratio. The next example is looking for an angle size given two sides of a right angle triangle. So again, we have this right angle triangle. It's good. It's 90 degrees. Which means we can use SOHCAHTOA. You don't have to write this down every time. Hopefully you don't have to write it down at all anymore. You kind of remember how to use it. Let's see if we can get this in focus for you. There we go, sorry. Okay, so again, we're looking for theta, right? Theta is just our Greek letter. It's our variable, it's our unknown. So what do we know relative to theta? Well, we were given 7, and this side is opposite of theta, and we're given 9, and you'll notice 9 is across from the 90 degrees, so it's the hypotenuse. So which of our trig ratios uses opposite and hypotenuse? And that's sine. Okay, so just like we would have done last year, we always write out our work. Sine is opposite over hypotenuse, okay, or sine theta. Sorry, remember you always have to say it's always sine of an angle size, never just sine by itself. It's always a ratio of an that's created by an angle. All right, the opposite of theta is 7. The hypotenuse is 9. Okay, so 7 over 9 gives us a decimal in our calculator. And what we want to do is we want to get theta by itself. So this is where we use the inverse function of sine on our calculator. Okay, so I'll get my calculator on the screen here. I'm going to go shift sine. So I get this inverse sine of 7 divided by 9. Okay, if you want, you can go 7 over 9 if you want to put it as a fraction. And your calculator might display that a couple of different ways. You know, you could go 7, oh yeah, that's all it's going to do. Okay, 7 over 9. I think it's just easiest to do 7 divided by 9 because that's what that line means, right? That's division. And then that's it. press equals, and theta is 51.06 degrees. And remember in applied, we're always looking for 2 decimal places in our final answer. And so if I was going to round this number correctly to 2 decimal places, I would have to round this 5 up to a 6 because the next number is a 7. And then we got to go back and see, does this make sense? Is this a reasonable number? Yeah, it's pretty reasonable, right? This 51 degrees, it's a little hard to know if that's about angle sizes, if it's reasonable, but these 2 angles are going to be pretty comparable in length, and it seems like a reasonable angle size, and it takes a little more practice to be able to know kind of what's reasonable or not. Okay, that's a very quick run through of about a week's worth of grade 10 trig in 10 minutes. So I hope that that makes sense. And I encourage you to do this practice. You need to read the notes over carefully, and then ask me any questions if you need to. Take care.